Good morning, everyone. So today we will have another example using chi-square method. So in this question, it is said that in an experiment, a dice is tossed 180 times. It is observed that the 5 spot side appears on the top 50 times. Are these different than from a mere chance? So what it means that from the question we understand that the dice was tossed 180 times, and from that 180 the the 5 spot side appeared on the top 50 times. So the rest of them appeared the rest of the other spot appear where the 180 minus 50 would be 130. So now we know that there are in this question we know there are two possible so in this question the dice, when you throw a dice, there are 6 possible outcomes from 1 to 6. So but the question here is that when the dice is thrown 180 times, the top 5 spot can be 50 times on the top. So the question is whether it was a mere chance. So we have to write it down as, so we have to write it down 5 spot side, non 5 spot side. So 5 spot side and non 5 spot side. So the 5 spot side that were observed to be on top was 50, and the non 5 spot side was observed to be 130. So was it a mere chance? So from this we can also see the row and the column of the question, which will be important in calculating finding the degree of freedom. So here there's 2 row and 2 column. So just for reminder, just write it down in the side. 2 row, sorry 2 row and 2 column. 2 row and 2 column. Just when you answer, you don't have to write it this way, but this is just for your understanding. So later it will be important in finding the degree of freedom. So okay, so now we have now we have this observed value. We have already know the observed value. So now we have to know about the expected value, expected frequency. Okay, so this is the FO, which is observed frequency, and then FE, which is expected frequency. So what would be the expected frequency? So because when you toss a dice, there are 6 possible outcome, that is 1 2 3 4 5 6. So what we do here is that, and the total number of times the dice was tossed were 180, and because when you toss a dice, there are 6 possible outcomes, so you divide it by 6, which equals to 30. So now here we know that the chances of 5 coming on the top when you toss a dice is 30%. Okay, so 30 times here, not 30%, 30 times. So so the known 5 spot side would be 150. So now we have to subtract the observed frequency from the expected frequency, and we see that from when we subtract FO minus FE, so 50 minus 30, it's 20, and then 130 minus 150, it's minus 20. So to find the whole square, FO minus FE whole square is 20 into 20 is 400. So if you remember, if you don't remember the formula of chi-square, I write it down here. Chi-square formula is equals to summation of open bracket by FO minus FE whole square, it's minus by FE close bracket. So this is the formula, and because so FO is the observed frequency and FE is the expected frequency. Observed frequency is the when we actually do the experiment, and the expected frequency, the theorized portion, what you theorize, that what would be the outcome, that is the expected frequency. So here we know the expected frequency. We have already found the value for the 5 spot side and non 5 spot side. So let us compute. So before that we have to form a hypothesis. So the hypothesis was step 1, which is the step 1 part. Hypothesis, the null hypothesis is that there exists no real difference between observed frequency and expected frequency. So this is now we have hypothesized this. So now we have to calculate whether and see whether we will accept our null hypothesis or reject our null hypothesis. So the step 2 is computing the formula. So this is the step 2. So we know the chi-square formula, so we have to calculate it now. So because we know that we have found the FO, FE and the FX square of the 5 spot side and non 5 spot side. So what we write it down here, this because the summation means sum of all the values, right? For the 5 spot side, FO minus FE whole square is 400 divided by the FE is 30 plus. For the non 5 spot side is the FO minus FE whole square, we have found it to be 400. So we will write it down as 400 divided by, now here the FE, that is expected frequency, is 150. So we will write it down as 150. Now calculating it using you can either use a calculator or it's a very easy sum. So the result would be, so now the result by using calculator we find that the value is 3 plus 15.996. Round figure would be 16. So we know we have found the value to be 16. Now we have to see, we have to check with the chi-square table, and to find the value in the chi-square table we have to find its degree of freedom. So then the step 3 is the degree of freedom. So the formula of degree of freedom is df equals to r minus 1 into c minus 1. So we already know from the, I have already explained that the row and column of the question is 2 minus 1, and the column is 2 minus 1. So by calculating it, we find it to be 1. So this is the degree of freedom. So now looking at the chi-square table, the degree of freedom 1 at 0.05 level and 0.01 level, we see that the value of 0.05 is 3.841 and value of 0.01 level is 6.635. Now the table for chi-square table degree of freedom 1 given value at level 0.05 is 3.84 and at level 01 is 6.63. So we see the value with round figure value 16, exactly is 15.996, so which is much greater than both the level value, greater than 15.996, 15.996. This value is much greater. So what it means is that because the value is much greater, there is a significant difference, and then there's a significant difference between the observed frequency and the expected frequency. And here the null hypothesis was that we have assumed that there exists no real difference, like no significant difference. But because if the value would have been smaller than both the value, then we would have accepted the null hypothesis and said that there exists no real difference. But because the value is greater than both the table value, that is 3.84 and 6.63, so we have to accept that, we have to reject the null hypothesis and say that there is a significant difference. So now what we will write it as, the obtained value is significant at both the level. In previous question, we found out that the observed value was significant at 0.05 level, but not at 0.01 level. So we wrote that it is significant at 0.05 level, but not at 0.01 level. But now here it is significant at both the levels. So we have written it as the obtained value is significant at both the level. So therefore, we reject the null hypothesis at both the level and state that the experimental result is not based on mere chance. Mere chance factor. Okay, so this is the sample number 2. I'll be sharing the sample number 3 in next video. Thank you.